Well, wastewater collection starts out at the home. So as people flush their toilets and take showers, that water runs out into the sewer pipe or collection system pipe in the street. By the time that water gets to the treatment plant, it's running in 48-inch or 4-foot diameter pipes traveling at an average velocity of 2 feet per second. So that's enough to keep everything in suspension. Once the wastewater gets to the treatment plant, we have to try to remove all of the material that can clog up pumps or be corrosive to pipes. So the first material that we remove is called wastewater screenings. And screenings is things like sticks, rags, diapers, anything like that that can clog up our equipment. So we have these automated screens. The wastewater runs through these automated screens and all of that material gets clogged up on those screens, and then it's raked off. The moisture is compressed out of it and it's put in a dumpster and hauled away like the garbage from your home. Then the next material that we want to move out from the wastewater is called grit. And grit is an industry term that refers to things like sand, rocks, pebbles, things that once that wastewater gets in the inside of pumps and starts being pumped at high velocities, it could scour or damage the inside of pipes. So we put that material in grit chambers where we slow the velocity down to a velocity of 2 feet per minute. That slows it down enough so that that type of material can settle out, but the organics, fecal material, and things like that stay in suspension. Then the next step is to separate the liquid wastewater from the solids wastewater in our primary clarifiers. And we do that in a settling tank that allows the heavier material to settle to the bottom, and then the liquids flow over the top of those tanks. Wastewater is treated by natural microorganisms, the same microorganisms that when bear and deer and fish use the bathroom in nature, those same microorganisms are the same microorganisms that we use in a wastewater treatment plant. So the liquid stream goes to what's called an aeration basin. We take air from the atmosphere, we compress it, and we push that air up through air stones or air membranes at the bottom of these tanks. That provides dissolved oxygen for these aerobic microorganisms. And then those organisms use the contamination in the wastewater as food. So our job as the operators is to make sure that the microorganisms have enough oxygen and that there's a good balance between the population of microorganisms that we have in the system and the amount of contamination or food for the microorganisms to dispose of. So we keep that system in balance and it gets treated that way. The solid stream then goes to anaerobic digesters. So digester, because it works similar to the digestive tract of all warm-blooded animal. So those digesters basically have two classes of bacteria. The first class of bacteria are called acid formers. So they take all the food that we eat and they break that food down into organic acids. And then there's a second class of microorganisms that are called methane formers. And methane forming microorganisms take these organic acids and convert it into methane gas and generate about 30% of the electricity that we need in this facility just by using the methane gas that's generated from this anaerobic digestion process. We've gone through the whole effort of cleaning up this water, getting it safe so that we can discharge it back into the environment. This is one of the most important jobs in our society, to maintain sanitation, to maintain a healthy drinking water supply. That's a very proud part of this job, is just knowing that essentially we are public health professionals.